So students, in this uh, uh, in this particular discussion today, it is in continuation to what we did in my previous lecture, that was of part 1. So today we shall discuss in continuation the empty set. So how do we define an empty set? Let us understand the definition part, and we would say that the definition of an empty set is that if a set which does not contain a set which does not contain any element is called the empty set. So simply we can also call it a null set or the void set. All have the same meaning, and it is represented or denoted by a Greek symbol phi, or simply put the parenthesis, and within parenthesis there are no element. So simply we can denote it like this. We can give some example of empty sets, and we call them, let's say for example, we say set A is represented as X such that 1 is less than X is less than 2, and we say X is a natural number. Now you may observe, or you may note in this discussion here, that between 1 and 2, a natural number does not exist. So we can clearly say A is a empty set. Similarly, we could say that X is such that X is n, X is an even prime number. X is an even prime number greater than 2. Greater than 2. So you could easily know that C is an empty set because 2 is the only even prime number. Similarly, we could possibly say yet another example. D is such that X is square is 4, X is odd. Now, obviously, if X square is 2, then X would be either minus 2 or plus 2. So the solution set of X does not contain an odd number. Hence, it is a null set or a empty set. Let us further understand what is a finite set, or we say what is a finite and infinite set and infinite sets. Let us say a set which is empty or consists of a definite number of elements is called a finite set. Otherwise the set is called infinite. Okay. Let us validate this statement through some illustrations. Let us say, let W be the set of the days of the week. So definitely we can call that the set W is a finite set. And then we can also call, if we have an equation, let's say x square minus 16. If we say, let's say x square minus 16 is 0, then solution set of S is finite. Okay. Let there be yet another set, say G be the set of points on a line. So what do we see? There can be infinite number of points on a line. So we will call then G is infinite. Okay. So let us understand through certain questions this phenomena. Let us say, state which of the following sets are finite or infinite. So let's say number 1, X is such that X belongs to capital N and X minus 1, X minus 2 is 0. Now if we look at this, what do we get? X will be either 1. So solution set of X is what? X is 1 and X is 2. So 1 and 2 definitely belongs to N. So we will call it that if we represent it with set, let's say A, then we can as well say A represents 1, 2. So what is the category of the set? We'll call it, it is a finite. It is finite set. So let's take yet another example. If I write X is such that X belongs to N and X is odd. So that means we are talking about infinite number of odd numbers. So set, let's say this is set B. So set B has infinite number infinite numbers of odd numbers, infinite number of odd numbers. So this is hence it is a infinite set. Hence it is a infinite set. Correct? Now let's talk about equal sets. What is equal sets? We can say two sets A and B are said to be equal if they have exactly the same elements and we write them as A equal to B. So a set, if two sets are equal, that means they must have the same elements, or we can say exactly the same elements. Otherwise, if this condition is not met, then we will call if A and B does not have exactly same elements, then A, we will say A is not equal to B. So equal set must have exactly same elements. Okay. So let's understand it through one illustration. Let us say find the pairs of equal sets, if any, give reasons, and you have got A as 0, B as x such that x is greater than 15 and x is less than 5. And then there is C where x is such that x minus 5 is 0. And then there is this D where x is such that x square is 25. And then finally there is E, and we write E as x is such that x is an integral positive root of the equation x square minus 2x minus 15 equal to 0. Okay. Now let us examine the condition. So A has got 0, B is a null set because x greater than 15 and x less than 5 would be a null set. C, solution is of C would be x equal to 5, and in solution of D, x solution is plus minus 5. This is your C and this is your D, and in E, x square 15 would be 5 3 so negative 5x plus 3x minus 15 as 0. So what do we get it? X minus 5 plus 3 x minus 15 is 0. So x here it is 5 actually. So x minus 5, x plus 3 is 0. So what is the solution? X is 5 and x is minus 3. But in question in part E, it says that you have to only the solution set is nothing but an integral positive root. So integral positive root is 5. So which pair meets the requirement? C also has 5 and E also has 5. So the only pair of equal sets are C and E. Hence, the only pair of equal sets are C and E. So I'm quite sure that you must have understood this topic. Through this, you can solve your exercise 1.2 of your syllabus. And thus, I conclude it here only. I will continue this chapter in my next video. Till then, thank you very much. We'll meet you again. Bye for now.